Hey, we've got a pretty important topic here, and we're just going to dive right into section 2.7. This is a chart that's super important. It's on page 151. I think you should find your book and go ahead and mark that spot so that we can flip back and forth and look at it. These are the steps that we're going to use to graph rational functions. We're getting ready to tie all kinds of things together that we have learned so far in this chapter. And this is the last section we're going to learn before we take our test. So I actually give you this, what you're looking at right now, for the test. You can have the directions. You just need to know what to do with them in order to make your graph. So let's dive into an example. We're going to do example 2. And they want us to sketch f of x equals 3 over x minus 2. And we're going to use the rules, the steps that we just looked at. So if you flip back to the directions, step 1 says simplify f if possible. Any restrictions on the domain of f not in the simplified function should be listed. I'm not going to talk that much about domain. So all we're going to do is simplify by factoring. And it said if possible. So this original equation that we have here doesn't factor. So it's done. We cannot simplify it. I'm going to go ahead and build my graph. Step 2 says find the y-intercept. Find and plot the y-intercept, if any, by evaluating f of 0. See, it tells you exactly what to do. So step 2, we want to find the y-intercept, and we're going to do f of 0 to do that. So you just go to the f function and put a 0 in for all the x's and see what you get. You get 3 over negative 2, which is negative 1.5. So now we're going to go to the y-axis and put a point at negative 1.5. That's our y-intercept. Step 3, find the zeros of the numerator, if any, by setting the numerator equal to 0. Then plot the corresponding x-intercepts. So step 3 is going to show us how to find the x-intercepts. And it says set the numerator equal to 0, if any. Right? It said if any. When we set 0 equal to 3, this is not true. So there are no x-intercepts for this function. Step 4, find the zeros of the denominator, if any, by setting the denominator equal to 0. Then sketch the corresponding vertical asymptotes using dashed lines and plot the corresponding holes using open circles. Okay, so since our function did not factor, that means nothing in the numerator divided out with anything in the denominator, so we have no holes. We can look to see if there are any vertical asymptotes, if you read the directions again, by setting the denominator equal to 0. So we have a vertical asymptote at x equals 2. Go to 2 on the x-axis and draw a dashed line all the way through your graph. Step 5 says find and sketch any other asymptotes of the graph using dashed lines. Right now to us, this is just horizontal asymptotes. You can look back at your notes, or you can look at the chart on page 144 to remind you of the rules for horizontal asymptotes. So horizontal asymptotes, we want to compare the degrees of the numerator with the degree in the denominator. So I can write that numerator as 3x to the 0 power, because anything to the 0 power is 1. So that means the degree in the numerator is 0, and the degree in the denominator is 1. So 0 is less than 1. N is less than m. The rule for n less than m is y equals 0. So go to 0 on the y-axis and sketch a line crossing the y-axis. Number 6 says, plot at least 1 point between and 1 point beyond each x-intercept and vertical asymptote. So what that means is, right now, our asymptotes have divided up this graph into these 4 sections, or these 4 quadrants. We want to know where the hyperbola is, or what the graph looks like. It could be like this and like this. If there was another asymptote down here, the graph might look like that. If there was that asymptote here, the graph might look like this. So we want to figure out, what's our graph look like? So I already have, so we're looking, we don't have any x-intercepts to check. We're looking on, this side of the vertical asymptote and this side of the vertical asymptote. So on the left of the vertical asymptote, we already have a point. We've got this point right here. So we're going to use that point to help us to sketch. We're going to sketch, I didn't really want to follow that axis. It might, but it might not. I'm just going to draw the hyperbola so that it goes through that point that we already have. More than likely, the other side is up here in this quadrant, but we need to check an x value over here to be sure. So we're going to check x equals 3, or 4, or 5, or 10, or whatever you want to check. I'm going to check x equals 3 by doing f of 3. So that's 3 over 1, or just 3. So that means the ordered pair x equals 3, y equals 3 is on this graph, which is right here. That's enough for us to know that this is the quadrant that our other part of the hyperbola is in. And step 7 just says use smooth curves to complete the graph. Rational functions have smooth curves, not points like absolute value graphs. So there's your first one, done. We're going to try another. Example 3. Sketch the graph of f of x equals 2x minus 1 over x. And I'll go ahead and build my graph over here. Okay, step 1, simplify. Does the numerator factor? No. Does the denominator factor? No. So it won't simplify, and nothing's going to mark out for us. So, nothing we can do there. Step 2, find the y-intercept. How do we find the y-intercept? It says to do f of 0. So, you're going to put zeros in for the x. Oops, got division by 0. That's a no-no, so no y-intercept. Step 3 says find the x-intercepts, and they say to do that by setting the numerator equal to 0. Add 1, divide by 2. That is your x-intercept. Go straight to your x-axis and put a point at a half. Step 4, find any holes or vertical asymptotes. There are no holes because nothing factored and reduced. Vertical asymptotes, it reminds us to set the denominator equal to 0 and solve. Well, we don't have to solve. We'll go to 0 on the x and do a dashed line through it, crossing the x. So it's the y-axis. Step 5, find any other asymptotes. For us, that would be horizontals. Our rule for horizontals, comparing degrees of the original. N is 1, M is 1. If N equals M, Then my horizontal asymptote is the ratio of the leading coefficients. So our horizontal asymptote is y equals 2 over 1, which is just y equals 2. So go to the y-axis, put a point at 2, and make it cross the y. So now these asymptotes have split our graph into 4 sections. We got this section up here, and these sections down here. So you see the way we divide those out. So I need to check some x values so I can figure out the rest of my graph. I already see this x-intercept here, so I know it's going to be like this. Sorry about all the noise in the hallway. It's probably also going to be here. So let's check an x value over there and see. Let's check x equals -1. Plug in -1 to the original. All that work to get 3. So the ordered pair is -1, 3. And it's where we thought it would be. So then you just draw the rest of the hyperbola through there, and you're done. We're going to do one that's a little bit more complicated, and then that will wrap us up for today. We'll learn about the other type of asymptote when we're together. I want you to look at example 4 in your book. It's a great example. I'm just not going to work it. I want to do example 5 with you. F of x equals x squared minus 9 over x squared minus 2x minus 3. Step 1, simplify by factoring. So the numerator factors, it's a difference of squares. So it's x, and 3, and different signs. Denominator also factors. 3 and 1, minus plus. So these are in both the numerator and the denominator, so we can divide those out. That means there's going to be a whole at x equals 3. So the simplified version of this formula or function is x plus 3 over x plus 1. We'll use that simplified version. So simplified, done. Y-intercept, find f of 0. And we can use the simplified version. So we plug 0 into it. Let me build my graph. So let's put a point on the y-axis at 3. Step 3, let's find the x-intercepts by setting the numerator equal to 0, and we'll use the simplified version. So go to -3 on the x-axis and put a point. There's your x-intercept. Step 4, let's find any vertical asymptotes by setting the denominator equal to 0. Go to -1 on the x-axis, cross it with an asymptote. And let's find the location for the whole. We know it happens at x equals 3. So let's plug 3 in. Whoops. This is the simplified version. So we have a whole at 3, 3/2. So let's go there and plot it. So 3, 1.5. Almost done. Let's do the y-intercept. Let's do the horizontal asymptotes. Let's look at our original degrees. They are equal to each other. So the asymptote happens at the ratio of the leading coefficients, which is 1 over 1. So the asymptote's at 1. Go to 1 on the y, cross the y. So whether or not we have to do step 6 depends on if I have points to the left and to the right of the asymptotes. So I know where to sketch my graph. And I do. We don't actually have to plot any more points. We can feel pretty confident that our graph is going to look like that, going through those points. Oh, whoops. 3,3 was a hole, not a solid point. Draw that as a hole. So when you graph through a hole, you do like this, and you have to pick up your pencil because that's discontinuous, just like the asymptote. The hole is a point of discontinuity. So there's your graph. Try these. Watch your video. Text me if you need me. We will go over some of these, and then we will finish this section on Thursday.